So we have some function h, and it says the limit of this function as x approaches a random number a is 1. So which of the following could be the value? Well,
Hey, how's it going?
good.
Can I give you 20 seconds?
Yes.
Use it as you like, but just make sure the information is shared. You sent me an email, right?
What? I'm confused. Oh, you want me to come in?
Alpha in this house. I'm the top dog. Right, guys? Right. Yes, thank you.
I Harold are top dog.
Which you can go times play tennis.
I got the which you may do
We have
Yeah, it has to be soon.
I missed your registration.
I like doing Justin, but
Alright, so coming back. Okay, maybe not.
I talked to George. No, not yet.
So, guys, when it says could, what does that imply to you?
Possibly.
Do you still need me?
Or later.
Yeah.
Okay.
Yeah, I'll just give it back to you if they're not.
Okay.
So he said possibly. I'm thinking more like that means that there's probably more than one answer. Okay. In other words, there could be multiple. Like you can see most of these, except for C, have multiple answers. So could be a limit of 1 means, like, let's kind of review from last week. What are we looking for to know that the limit is 1? Does the function's value have to be 1? No. Okay. So that means we have to look at anything that crosses y equals 1 and look there, right? So could this, or does this limit at, what is that, x equals -2, is that 1?
Yes.
Yeah, so that's good. Okay, and then I see that one. Is that limit 1?
Yes.
Here? Okay, we're going to talk more about that today, so I'm glad you're saying yes, because it's actually not. How about the limit here?
Yes.
Yeah, that's 1, because not only does it go through there, but it's the same from both sides. So I should be circling these. Okay, and then the line goes through that point, 1. Is that a limit of 1?
No.
What is the limit at x equals 3? It's up here, right? At 3. Okay. So where are we there? -2, +2. So you should have chosen B. Good? I'm going to hand you this. It says end of class, but. Any questions on the homework problems from yesterday or from the other day?
No.
They kind of seemed like they were okay, pretty easy. Okay, you guys are checking, right? You're checking your answers.
Yes.
Okay, because I'm relying on you to get that feedback by checking online, and then we just do them if you're stuck. So let's do this. Check in fist to 5. Fist, I'm clueless. 5, solid on what we've done so far, which is what is a limit, kind of how do we find that, those kind of things. Okay. So it looks like overall we're feeling pretty good with this. I do want to define a limit. So today's job, we're going to try to do 2 sections because they're, excuse me, geez, they're pretty closely related. So we're going to try to do the next 2 sections in your packet. One is estimating limits. I mean, that's our overall goal from graphs, but then also tables. So you will need a calculator for the tables part, and definitely a graphing calculator is way easier for this. Did you guys study one-sided limits in pre-calc?
Yes.
You say yeah, you say no. Don't remember? It's pretty easy, I think. Basically, it's the idea of what's the limit as we come from the left and the right. That's all. Okay, and so in the warm-up problem, a couple of those points had different limits coming left and right. Before we do that, I want to put a more like an actual worded definition of a limit. So I should say that limit definition. I think we're probably there. If I asked you to define it, I think you probably could, but it's nice to have that. Does anybody want to try before I write it? Just to see kind of where we are. If I said what is a limit, what would you say? So Friday we talked notation, which is almost the definition. Nobody? Roger, thank you.
Thank you, Pedro.
So it's the value a function approaches. In parentheses you can say, but doesn't necessarily reach. As x approaches arbitrarily close to a value. Oh my goodness. Come on. Arbitrarily close to a chosen value. It's that whole idea of implied value, but not necessarily actual value. One way that you could think of it, if we want to like paraphrase this, is the intended value of a function. Or I'm just going to say intended value for now. So that hopefully will shed some light on the left and right idea. So one-sided limit is the y value as you of a function approaches as you approach a given x value from either the right or left. Or left or right side. Okay, next. This is going to help you kind of sort out the warm-up. For a limit to exist, we have to meet a couple of conditions. So the left and good grief, do you see that shaking? The left and right limits must be the same value. And the limit must be finite. What does that mean? Well, just as a reminder, from Algebra 2, but also from pre-calc. So let's say we have a function that looks like this. Does the limit exist? Like as x gets closer and closer to 0, it's doing the same thing on both sides, right? So that first condition is met. The left and right limits are the same, but it's going where? Infinity. Is that finite? No. So this one has no limit because those are finite value or infinite values. Okay? So left and right hand limits. Hopefully if you have studied this you'll remember notation, otherwise it's really simple. So what is the limit as f approaches 3 from the left? So remember it's the intended value of the function. We're sweeping in here from the left. What is the limiting value of the function? Negative 1. Okay? So we write that, and I'm going to write it bigger. Actually, I'll just write it up here so you can actually fit it on there. As x approaches 3 from the left. So you put that little minus sign up above where an exponent would go. Don't confuse this with negative 3. Especially if our limit was, if we were asking about negative 3, we would have negative 3 and a negative sign above that. So it can get kind of confusing. So it's negative 1 coming in here sweeping from the left. From the right hand side, it's different. So the limit as x approaches 3 from the right. Now we put the plus sign. We're coming in from the positive side, if you want to think of it that way. Of f of x is what in this case? Well, it's 2. Okay, so if we're think about this function continuing up like a parabola. If we're coming in this way, we're stopping at 2, whereas this way we're stopping at negative 1. So that's all that means. Well, going back to our 2 criteria, this first one fails. The limit coming from 2 different sides is different. So the limit, now we're going to drop the sign and just say the limit as x approaches 3 of f, what do we say? Does it meet the 2 conditions? No, so what do we say in that case? Does not exist. Okay? So the 2 sides have to be the same. Easy enough? Yeah.
How come, like, when we're doing in our homework, like, usually if there's a point above, then we count this?
Yeah, so let's go back to that warm-up problem because it had some in there like that. So like this point, I think is what you're talking about, right? So coming in from the left, what's the limit? Like what is the intended value of the function coming from the left side?
3.
It's 3, and then coming from the right, it's also 3, right? So the limit is the same from right and left, and the limiting value is finite. It's 3, so that limit exists, even though the function's value isn't that. Is that what you're asking?
Yeah, and then also, like, with 1, like, what happened 1 was
Okay. Here?
Yeah.
So coming from the right, what's the limit?
What?
What's the limit?
Negative 1.
-1. Coming from the left, what's the limit?
1.
It's 1, so they're not the same, right? So the limit at 1 doesn't exist. Now did that answer your question? Any others? Any other questions? So why don't you take just maybe a minute and a half to fill A through I out and see how that goes. We'll check it. So I'm gonna just write answers in here, and then you can ask me if you have any questions. Sorry. How'd it go? Good. Why is this one DNE? So think FRQ. Does the limit exist? If not, explain why or whatever. Why on part C? What would you say as to why it's DNE? Does not exist? And think FRQ language. You know, you have to kind of explain stuff. Are you thinking? What were you gonna say?
Because f of x coming from the left here, just rough here, like, you know, rough. F of x coming from the left and f of x coming from the right are not equal. F of x at x equals -2 does not exist.
The limit of f of x. Yeah. Okay. So use that technical language. You'd have to say the limit as x approaches -2, thank you, from the left equals, give the value. Limit as x approaches -2 from the right, give the value. Because the limits are not equal, the limit as x approaches -2 does not exist. Okay? FRQs require very specific language. Alright, we're sketching a graph of a function that satisfies all these conditions. So, g of 3 equals -1, what goes there? Just a point, yeah. Okay, the limit as x approaches 3 of g is 4. How does that look?
4 and then like
Okay, so we're approaching 3, but up here at 4. And so you can do this however you want. Like I'm going to do this and then just bring it down for now. So my limit as I'm approaching -3 from the left, or +3 is 4. Okay, part C, limit as x approaches -2 from where?
From the right.
From the right is 1. So as I am approaching -2 from the right, I don't know, just bring that line down or curve it or, you know, do something fun. Maybe it's like that. Whatever. Okay? Do we have to be specific to meet the conditions of the problem? No, that's good enough. G is increasing. Now we might have to, because we're reading a new condition, on the interval -2 to 3. So is this still increasing, even though I put that little cusp right there?
Yes.
Yeah.
Yes.
All right. Limit as what?
Limit as x approaches -2 from the left.
Perfect. Is greater than where it came in from the right. So what do we do with that?
We could do like a line coming from the left that means at -2, 4. or
Okay.
something.
Yeah, like put it up here. So maybe it's coming in like that. Now we just have to decide what we're going to do at those 2 points. So can I do 2 solid circles?
No.
No, because then it's not a function, right? That would be 2 outputs for 1 input. So make one of those an open circle. And there you go.
And it has to be an open circle at 4.
I could have made the other one an open circle. It's okay.
What about coordinate 3, 4?
Yeah? Well, what about it?
Doesn't that have to be an open circle?
Well, it never told us. Yes, it does. Thank you. That's huge open circle. Yeah. Okay. If you get a problem like this on AP, go back through and double check that your graph matches the condition of the problem. One thing to note, again, this could have come down or been straight or linear. Like the graph doesn't have to look the same. So I don't want to take time, but go through and check that you've met the criteria. Okay? And we're good. Questions on graph, finding limits from graphs? Everybody's good on that? Alright, flip the page for the work. And circle 4, 5.
6, 7.
4, 5, and 6, 7, 8. 6, 7, 8. All right, grab your calculators. We're not going to use it right away, but we will here in a couple minutes. What? You good?
Yeah.
All right, so next is just the same kind of idea, only from a table. Which hopefully, if as you're thinking table, you're thinking, yeah, that's definitely more work, or could be. Okay. So if we have the graph, it's easy to see the value. Like here is what, as limit as x approaches 3 is 4. Can you see that in the table? How? Like I think we all can, but let's put it into words. What are we looking for in the table to know the limit is 4 as x approaches 3? Well, I don't think I would say it as it skips it, because sometimes it's okay for it to be that number, right? What does this mean? I think you have a good idea.
It approaches it from the left side and the right side.
Okay. So hopefully you're used to reading tables like this left to right, but when you look at your x value, so obviously here, you want to come in, even though we're reading left to right, come into it from the right on the other side. Okay? Okay, so we're seeing that's 4 coming in right here. How close does it have to be for us to believe that it's actually 4? Thoughts on that? Like, is 3.99 and 4.01 close enough? Okay, well, since it's the intended value, is that good enough for us to think that it looks like it intends to be 4?
Yes.
Yeah. I mean, with tables, we have missing data, don't we? Yes. On the graph, I mean, we know everything about this right up until the point, but in a table, it's discrete data now. It's piece by piece by piece, so we're going to have to do our best and estimate. So we know it's going to fall in here roughly 4, okay? So how about this one? The limit as x approaches -4. What are we saying? Yeah. 2.5? Okay. Is there a possibility that this right here between these two very close numbers, that this graph maybe dips down or something that we don't know? Or maybe it skips it, but again, it's the intended value, so it's telling us where to look. What if we don't have a table, but we're told to use one? Now what? Well, 2 things. One, this is where you definitely want a calculator. I'm going to show you 2 ways to use it. But number 2, and probably more importantly, you have to pick your own values now, don't you? So if it wants the limit as x approaches -2, what kind of values are you going to plug in here to get that? What are good ones? In fact, let's put a statement over here. Plug in, and you guys fill in the blank. How would we decide what numbers to use? So don't write this, I'm just asking the question. Like, is this good enough to tell us the limit? Because they're nice whole numbers, it might be kind of nice. How come? I'm seeing lots of no head shakes. How come? Yeah.
Because that's just, I guess, showing points on the graph. I think we should use numbers to intend. Just like the intended value is that, but we're not there at the same part as on the last ones.
Okay.
So using
So get closer. Okay, so now he's suggesting this. I'm going to leave -2 there. And he said -2.1, -1.99, or 9, I don't know what he said, but is that close enough? Or could we get even closer? Like, is there space between 2.1 and 2?
Yes.
Or numbers, I should say, yeah. Okay, so it's a little bit of a preference, but we do need to be pretty close around it. Now, here's the other version. Does this need to be like this significant to tell us? Probably not, but potentially yes at the same time. Okay? So, what values do you want to pick? Here, which do you want? What number? You pick this one, Matilda.
Minus 2.05.
5?
Yeah.
Okay.
And we always get closer.
And then we'll go -2 point what? Dutch.
0, 1,
Let's get a little closer maybe.
0, 0.
Sure. Okay. And then how about Manuel coming on the other side? What do we want?
Probably -1.99.
Okay, Chloe. So don't stress, it just has to be bigger than this one, right?
Yeah.
Like bigger meaning further right. So
0 number? Or
like that?
yeah.
Okay. Alright, so let's put a statement here. Plug in what? Or pick X values that are what? Alright, I'm going to say it this way. Sufficiently close to x equals a. What is a in this case?
2.
-2, okay. Alright. Grab your calculator. I'm going to show you the numworks one, of course. That's what I'll always do. And you open it up to this screen. Calculation is the normal calculator screen. We want to go to Grapher because that's where you enter. It's one way that you enter function rules. So go to Grapher, Home, Grapher. Add an element. That's where you're adding your equation. So that's a big deal in this one, right? In fact, it's going to be hard for me. I'm going to have to pull it out of here so I don't have to flip back and forth 50 times. Okay. So, looking on there, should we put parentheses around the numerator? If you have yours, go ahead and do this. Your X numbers are right here down below the black power button. So X, and then cubed is the X to the Y button over here to the right. So X cubed. And once you kind of learn where stuff is on this calculator, I think you're going to find it not a lot more palatable. Except for look what I'm doing. What did I do wrong?
It's all in there.
You stayed in the X.
Yes, I do that almost every time.
Oh, you didn't do
Thanks
that.
for telling me, by the way. Good job.
Anytime.
You're going to wait till I got the whole thing done, I think. Alright, good there. And then check this out. When you hit divided, it creates a fraction for you. So like the TI, it's just still in the same line. It's not very visually appealing. X plus 2. Does that one need a parentheses in the denominator?
No.
Probably the top one didn't either. I still get used to doing it with the TIs. Okay, and then EXE, that's like, it's short for execute, so it's like enter, okay? So you can hit execute or enter, and now it's locked in there. Okay, arrow up to the top ribbon, expressions, graph, etc. if we wanted to see this graph, there it is. Okay? We'll talk graphing some more later, but for now, I'm just going to go over to table. Okay, so it defaults to 0, 1, 2, etc., just counting by integers. This is nice. You don't have to change a setting. You can just go type in what you want. It's cool. Okay? So our first one, let's see what we wrote. Negative 2.05. Negative and minus is the same button on this calculator. So you don't have to like figure out which one to push. So negative 2.05, execute or enter, and now we're getting a value. Sweet, right? Okay, our next one I think was 2.001. Okay, negative 2.001. Execute. Okay, negative 2. What do you expect to happen on negative 2? If you look at that denominator, what's going to happen? Yeah.
It's going to be undefined.
Yeah, can we do a negative or a 0 denominator? Okay. All right, another nice thing about this is it actually says undefined. It doesn't say error, like you did something wrong. It's very clear, undefined. Okay, next one, 1.99. Negative 1.99 and negative 1.099. Okay, there we go. So there's our table of values. Let's go fill it out. This one shows, like here, it's showing 4 decimal digits and then more on a couple of those. What does it look like our limit's probably going to be? Kevin, how about you? Yeah, like, dude, you're in a calculus class. Pay attention. What does it look like our limit's going to be? Help him out. Devin, help him out. Like this is basically our table. It's just vertical instead of horizontal. What is it look? What is it looking like our limit will be?
2 or negative 2, sorry.
But that's the x value. Okay. Well, let's go write these values in. Do you have them in your numworks? These?
Yeah.
Okay, so I'm just want you to tell me them so I can write them in. Devin, I'm coming back to you, so make sure you got this. Go.
21.502.
Okay.
Negative 3.001.
Something happened there. It should be here.
I didn't do negative.
Oh, okay.
Negative 2 point.
Okay.
And then 21.01.
Okay, and then this is undefined.
And 20.900 and 12.728.
Okay, so just to point out, do you see how this one's pretty far away? So we could have maybe done like 1.9 here, and it would have brought that closer. And you can always change it. That's the nice thing. But anyway, Devin, back to you. So the limit as x approaches negative 2 looks to be what?
21, sorry.
21. We all agree on that?
Yes.
20. I don't know what's the problem here, but 21. Okay. All right, another way to do this. I think I showed you the table of values on your calculator. Function notation is cool too. Let's go to the calculate screen. So just hit home and calculation. We don't need those numbers. I'm going to get rid of them. Okay, this calculator is super easy to define a function and then just plug it in. So I don't want to plug that whole thing in. I just want to show you how to do that. Let's say our function was 8x minus 5. So I would type 8x minus 5. And of course ours in this particular problem, there's a bunch more to it. Okay, do you see this little arrow right here on the x to the y button? You need to get a calculator if you're not looking at your own. It's a little arrow pointing to the right, and it's the store button. So you'll see it just be an arrow on there, but it's saying store this as something. You could store this as f of x by doing, okay, alpha gets us to be able to type alpha, and somebody with yours, can you help me because I can't read the letters? F, there it is. F of x. Oh, come on. There we go. Okay, so now this is stored as f of x. Now I can plug in anything I want to. So I could do alpha f of what? Oops, I cannot read this. Alpha f, there we go. F of what? Pick a number.
27.
27. Okay, and now it spits out what f of 27 is. Okay, so this is another way you can use the calculator to get those values in your table, and just do f of negative 2.001. Negative what?
That's a cool.
I can tell that I'm going to have to show you once you get your calculators, but please do that. I want your calculators here by Thursday, no later, okay? Get the forms turned in and paid. We'll have to come back to this one tomorrow, but I think that's probably enough for you to get some of these problems done. So circle circle 6 and 8 on that one. So we only got up to there. 6 and 8. We'll pick up the rest tomorrow. And again, having that calculator will help. Yeah.
What's the name of the calculator app?
Oh yeah, you guys, this is just an online emulator. It's just, if you just type numworks, it should be one of the first choices.
Okay.
So you can use it on Google for tonight at least.
Thank you.